Hi guys, Neil here again. Today I'm going to have a chat about silage as a food for cows and the impacts it has on cheese. So firstly, what is silage? It's a type of fodder made from green foliage crops, grass, etc., which may have been preserved by acidification. Usually is by fermentation with bacteria, turning the grass or other forage crop acidic. And this is achieved through its fermentation. And it can be fed back to animals with little loss of the basic nutrients from the time it was in the native form of grass. So when the pasture is converted to silage, sugars are converted into lactic acid by bacteria. It's lactic acid which actually pickles the pasture, very much like yogurt is pickled milk. And that allows it to be preserved for a lot longer than it would be had it been left in the open air. So what can happen if the silage is poorly made? It can contain bacteria known as spore-forming bacteria, such as Clostridia. These can come from the soil, particularly if the grasses are harvested for the silage too close to the ground. And the bacteria, these Clostridia bacteria, can contaminate the silage. These bacteria can survive the pasteurization of cheese and grow in the cheese during maturation. They in fact utilize or use as a substrate for their own fermentation in the cheese. They use lactic acid, and they produce butyric acid, carbon dioxide, which is gas which causes blowing or late blowing, hydrogen, acetic acid, and a couple of other byproducts which are not that pleasant to taste. These butyric acid bacteria cause what we know in the industry as late blowing, or sweet cheese holes, or late blowing of cheeses such as Swiss or Edam, Gouda. Generally not a problem in any cheese which has got a lower pH, which is more acidic, more when the cheese is less acidic. So late blowing often coincides in Swiss and Edam and Gouda type cheeses when the pH levels of the cheese start to rise. And it's during these conditions that the spore-forming bacteria tend to thrive due to the decrease in acidity. They don't like acidic conditions. So for most cheeses which are more acidic, they won't be a problem. So the decrease in the acidity is the result in Swiss type cheeses of other bacteria like Propionibacterium, which actually produces the eyes in Swiss. They actually utilize lactic acid and de-acidify the cheese. So how can we reduce the impact of these spores during maturing? There's a number of ways. One of them is adding nitrates, something we commonly know as saltpeter. Potassium nitrate or sodium nitrate can be added to the milk, and it's often added, and it's legally permitted at certain quite low levels. These nitrates themselves do not inhibit the butyric acid bacteria, the Clostridium bacteria, which, as I said, survive the pasteurization and the spores can grow, but it doesn't inhibit the bacteria or prevent the gas production. Well, what happens is that the nitrates, when added to milk, are reduced to nitrites by an enzyme in milk that's naturally present, known as xanthine oxidase. And these nitrites, which are produced, are toxic to the butyric acid bacteria and to lactic acid bacteria and to people, of course. So the nitrite levels, though, seldom exceed 2 to 3 parts per million, and they disappear throughout the months of maturation. And by 3 months, the cheese has got no nitrates, and it's about that time or after when the cheese is consumed. Another more friendly way of controlling them is to use an enzyme known as lysozyme. The technical name of a lysozyme is muramidinase, but I think lysozyme is a much better term. And it's a recommended additive when blowing from butyric acid bacteria are a problem and you don't want to use nitrates, or you're not allowed to use nitrates. The lysozyme is present in very low levels in cow's milk, but is also found in high levels in egg white. So if you see on a Swiss cheese, a Jarlsberg or something of that nature, the presence of an egg products, it'll be because lysozyme has been added to control the spores. It is effective only, though, against low levels of spore contamination. So if the spore levels are any higher than about 500 mils per litre, then it probably won't be very that effective. The typical levels that are used in milk do not interfere with the starter culture. Another method is called bactofugation. It's not an additive, but it may eliminate the need for nitrates and for lysozyme usage. Bactofugation is intensive centrifugation using high speeds of centrifugal force with continuous removal from the centrifuge of a small amount of skim milk, which is called the bactofugate, which carries with it most of the bacteria present and pretty much all the spores. That bactofugate is put through a UHT process. It only represents about 2% of the total milk. It's sterilized, the spores are destroyed, and then it's re-added back to the milk before pasteurization. Now, a bactofuge is really the domain of a very large company because they cost mega dollars, and so only large companies can actually afford to buy them and utilize them. It's extensively used in Europe, but seldom in New Zealand and Australia. And bactofugation can be preceded by conventional filtration to remove other debris, but yes, so it's not really available to small cheese makers. Okay, so that's about it for today. We shall now end this session. I hope that's been informative. Cheers.